Vertical alignments are subsets of horizontal alignments. So that is why we see in our workspace bar here that the Cooper Street horizontal alignment has underneath it a vertical alignment. So each vertical alignment is associated with a horizontal alignment, and there can be as many different alignments as you'd like. In order to view a vertical alignment, you first need to create a profile. In order to create a profile, you go up to the evaluation menu, profile, create profile, so that we can create a profile and then view our vertical alignment. Alright, on this general tab here, this is the create profile dialog that has all of the settings for creating a profile. So we want to call it Cooper Street. We can give it a set name, Cooper Street, which we'll see where the set name is displayed, and then we can either have it go from left to right or right to left. Now typically we work left to right, so I'm just going to leave that left to right, and then the exaggeration is similar to the scale. So if you want a much more horizontal profile, then you can scale that up, or in this case we're just going to leave these as 10:1, and we'll see as we go through here the different exaggeration. I'll go back and show you, and then you can play around with it as well. The surfaces here are the two surfaces that are in InRoads currently, and existing ground is checked because that's the active surface and we want to keep that way, so we're going to leave this checked on. For our source, what we can do is either, we'll see when we go into create cross sections as well, that you can create them from a number of different sources. You can either use the alignment, which in our case we're going to use the Cooper Street alignment, but you can also use graphics to choose graphics from MicroStation to use as your alignment, or you can use multi-point, where you're actually creating those points for the purpose of creating the profile. And lastly, you can open up a ASCII file if you check this, and then you go down here and you can browse and import that ASCII file into, or a text file into the create profile dialog here. So we're going to leave this set as the alignment. Include, these are all the surface features that we could include if we would like to. We're going to leave them set like this, and then offsets as well. So there's all these different settings for displaying our profile, and we can set either a given elevation or only a portion of the stations, and that would be set here in the limits. Axes and grid, these are just options for displaying the profile in the way you'd like. Why don't we just apply this first and then see what it looks like so that we can see what we're dealing with. Now it wants me to identify location. When you're identifying the location, keep in mind that you're identifying the lower left corner point of the profile that we're creating. So if I left click right here, if I close out of our dialog, we can see that this is where I left click, and that is the lower left corner of our profile. So if I zoom in, this is our set name that we had set in the create profile dialog, along with the existing surface that we see here. If we zoom in, these are our stations, our elevations, and we have a little legend here to denote the existing ground surface displayed in that green dash line that we've seen before, and it's scaled using the exaggeration 10 times vertically and 1 time horizontally. Just to give you an idea of what that exaggeration does, if we were to go in here and create a new profile, Cooper Street, we're just going to call this 2, make it 10 times horizontally, apply that, we'll apply it down here. We can see that it's now, for each one of these stations, it goes from 10 to 11. It's 10 stations in this first profile. So we can see here that it's now scaled 10 times horizontally. Alright, I'm going to go ahead and use my MicroStation tools to delete this because we don't want to work with that one right now. So now we're working with our profile here, and what we can do is view our active vertical, since we created that profile so that we could view our vertical alignment. Under the Geometry tab, go to View Geometry, just as we have been before. We're going to go to Active Vertical. We'll display our vertical alignment. And there we have it. We see it shows up here in this red, solid red line that is similar to the horizontal alignment that we saw here. So those are again set in our preferences file that we opened up. And we can see here that it follows, for the most part, the existing ground surface with just minor tweaks that would need to be made. So that is how we would create a profile and then view the active vertical alignment on that profile. So if I went in and made multiple profiles like we did before, I'm going to change this back to 1. Apply that down here. Now as we see in our next example or exercise, we are going to annotate that vertical alignment. So if we go to Geometry, View Geometry, Vertical Annotation this time, so instead of annotating the horizontal alignment like we did, we're going to annotate the vertical alignment. We can see here, if I move this out of the way, that red box, our favorite red box that shows the active element, so either in this case the active geometry project with the active horizontal alignment, active vertical alignment, and our surfaces, our active surface here. Well, it's the same thing here. This is our active profile. This is the profile that is going to be displaying our vertical annotation. We can change that. Over here we see our profile set. This is our second profile set down here. But since we already are viewing the vertical alignment on the first profile set, we're going to use that one. And here we want to, this is our only vertical alignment that we have in our file here. So we're going to leave this set as Cooper Street Vert. And then horizontal alignment, we're going to keep as Cooper Street as well. As usual, we can set the limits if we don't want to use the entire alignment. But in this case, we want to annotate the entire alignment to give you a sense of what it looks like. So I'm going to apply and close so that we can zoom in and look at some of these annotations. So like we had before, we have a grade and tangency, or tangent length. So this is similar to the horizontal over here where we have a tangent length and a direction. We now have a tangent length and a grade. The points of vertical intersection and points of vertical curvature are shown with these yellow lines and highlighted by these lines showing to where they're talking about. So if we zoom in here, we can see that there's also, right next to this point of vertical curvature, there's actually a high point at the 11+06.83 station with an elevation of 205.22. Along with the grade and tangent length, as well as the points of vertical intersection and curvature, there are also these annotations here on our vertical alignment. This is showing us that it's a what type of parabola this is, or what type of element this is. In this case, it's a symmetric parabola, and it's a crest curve, so it has a crest arc to it with its length and its grade in, grade out, as well as some other coefficients and sight stopping distance. If we zoom out over there and then zoom in, on this one we see that this is also a symmetric parabola, but in this case this is a sag curve. So we have the crest curves and sag curves, again with its length and grade in, grade out, with its sight stopping distance. And we notice here that this is the low point. So we saw the high point at the beginning of the alignment over here, and we can see that the low point is right here with an elevation of 200.37 feet. Alright, so there we can see all of the annotation that is done using that vertical annotation tool.